Hello, it's September 14th. It's one day after we did the fiberglass. I'm just going to do a quick video, show you that we have the tubes here drying. If you recall, the booster, the main booster tube and the booster extension were just done in the single 5-ounce mesh. So you can kind of, I don't know if the video can pick up, but you can kind of see there's a slight texture to the mesh. We still have the caps on. I'm going to let this set up for another day, so it's been 24 hours, but it looks pretty good. We had some drips on the two that didn't get the Teflon. The nice thing about the Teflon coating, you can see how the adhesive actually wicks up. It's almost like wax. It pulls the excess epoxy out and wicks it up to the surface, and then it dries. So if this works as it's supposed to, we'll peel this layer off. It takes the excess epoxy off and leaves a really nice smooth finish. So these are not as smooth. In hindsight, I probably should have wrapped these in the Teflon as well. Maybe would have had to sand it a little more to apply the second coat, but in this case maybe not as much sanding. So once these two are bonded together, we'll do one solid layer of 3 ounce, which will hopefully hide the seam. So the two that have the Teflon is the eBay ring, which you can see I've already started pulling a little bit there, and this is the payload section. So tomorrow I'll videotape as I pull these off, so you can kind of see what they look like. These will pretty much look like what they do now, but I'm just going to leave the end caps on until tomorrow. We'll separate all that. One change that I did make, the engine tube. If you recall, I was saying I was going to do the engine tube first last week in fiberglass and kind of see how it went. And there was 2 techniques that I could use. The first technique that I had seen on YouTube is where you actually lay the mesh out on a piece of Mylar and you coat the mesh completely, saturate it with epoxy, and then you literally roll the tube over it like rolling out a dough, and the idea is it cleans and you roll it out. Once you're done with that, you then wrap it in Mylar. The mistake I made is the thickness of the Mylar was too thick, so the rolling went okay, but then when I put Mylar around it, the Mylar was very stiff and it tried to open up, and so while it was drying it actually pulled away, and in doing so it lifted the mesh up and it dried. So I've got all these bubbles in the engine tube. In fact, I'll get the engine tube and show you. So this is the engine tube. You can see this side came up pretty good. This is just one layer of the 5-ounce mesh, but you can see where the Mylar pulled away. You can see there's air underneath here, so it's a hard coat, but it's got air, so that means it's lifted from the cardboard. And the extreme case, the bubble was so big, you had this huge bubble, and I had to cut it out. And the problem is, with it cut out, you got epoxy, but see, I can still flex this with my finger. Maybe you can't see it, but I can feel it. So that taught me real quick that I wanted to change my approach, which is the approach I ended up using yesterday, where I put it on the rod and we basically we coat the tube and roll the tube on the pole and roll it out like I did in the video. That proved to be a lot better technique. So, you know, rather than trying to salvage this, I thought, you know, I'm really pushing the limits on this rocket, so why don't I just forego the cardboard tube, and instead I bought a solid fiberglass. This is a solid fiberglass tube, so a lot stronger. So this is going to be the engine tube. This is same inner diameter, and we'll actually put the ring on this tube. I can do it with one hand. You can see the engine is like this. So tomorrow I just sanded this tube down. So I sand it with rough 60 grit paper. That way you can do epoxy to it. And that gets rid of the mold release. You can kind of see the roughed up sandpaper pattern. And so I'm going to let this dry tonight with the acetone. Tomorrow I'm going to use JB Weld. JB Weld is a very heat resistant epoxy. So I'll glue this motor mount ring to this tube tomorrow with JB Weld and let that set up for a while, and then we'll be ready to start putting the fins on this piece. And by then we'll be able to remove the film tomorrow, and those tubes technically will be ready. So we'll start working on the inside. Alright, till next time. Bye. Hi, today's Tuesday, September 15th, and we're 2 days since we put the fiberglass on. So this is the payload tube, and if you recall, we did a 5 ounce, a 3 ounce, and we put the Teflon release film on it. So I'm going to take that off now. If you recall, there was two rows of that. So I basically pull off. Come in closer if you want.
I'm zooming.
So you can see how the epoxy wicked to the surface. The whole idea of the Teflon is that the adhesive doesn't stick to it and it wicks out the excess adhesive, which ultimately, if it works, gives you one layer of a nice uniform layer of fiberglass when you pull it off. You can see it's coming off here. Comes off. Alright, so discard that. You can come in close, you can see. So we got a nice smooth surface. Got a few areas that may need a little bit of filler, but very smooth texture. So the next thing we need to do is take the end caps off. So we take that off like so. Taking the tape out, the caps helps them come out. There's actually two tubes in here. So we push to get it separate because we have the Teflon tape. Epoxy shouldn't stick to it. So we break the seal. Intentionally went over with the epoxy to make sure we got plenty of coating. We pull that off. And you can see because of the Teflon tape, the inside of the tube is dry. There's no adhesive that wicked over the side and into the tube. So basically I'll just use a Dremel and with a grinding blade in it and just grind out the surface to smooth these up. So we take this one off. Same way, take the tape off. Break the seal. It should break pretty easy with the Teflon tape on there. And we pull it off. Pull the Teflon tape off. And again, the inside of the tube is very dry. No sign of any of the epoxy wicking on into the surface or the inside of the tube, which obviously would cause a problem with the other couplers. So you can hear it's pretty hard, and it takes on kind of a textured of the of the Teflon film. So really this is ready for painting. You could shoot paint right on this. You don't want a glass surface. A glass surface you would have to rough it up with 60 grit paper. So this is a finished product. Now if you recall, the booster and the booster extender got just the 5 ounce, so you can see the texture in the light of the 5 ounce of coarser grit. So some areas where the epoxy was kind of heavy, it's almost of a glass cover. We didn't do any Teflon release on this. So the idea is these two tubes will be glued together like so, and then we'll wrap the continuous 3 ounce and then the Teflon to basically make this joint here invisible. So we'll bond these two with a coupler, we'll sand it up, make it smooth as we can, and then we'll do the 3 ounce and the 4 ounce. This is the eBay ring. It was done with the same procedure there. So this has 2 layers, the 5 ounce, 3 ounce, and the Teflon release of that little section is done. And these are the actual end caps to the eBay. And I had read up where they like for you to put fiberglass. This is made out of wood, so we put fiberglass coating, which I did on both of these sides. The idea is the black powder charge is on the outside, and I've read where if you put a fiberglass coating, the black powder doesn't get into the grains of the wood and it doesn't create a big mess. It's easier to clean off. So we also fiberglass those two halves as well. Okay, until next time.
Bye!
So this is after we cleaned up the edge. So basically again we just use the grinder with a grinding wheel and cleaned up the edges. Doesn't take a lot because it's just epoxy. It's not doesn't have any of the mesh in it. If I did it right, if the mesh stopped or the weave stopped at the edge. So you might could see in the light the coarser pattern from just doing the 5 without the 3 and the Teflon, but yet you can see how much finer and smoother this is. So again, these are the two booster sections. Sorry about that. 2 booster sections, and then this is the payload section, and this is the eBay ring. So I went ahead and cut out the fins while I was doing the grinding. I cut out. So the next step we're going to do is glue the engine retention ring onto the motor tube, which I showed you is fiberglass, and we'll do a whole alignment and start getting the fins ready to put into the unit. Okay, so it's Thursday, September 16th, Thursday after we did the fiberglass of the tubes. Tubes, as you saw earlier, have been trimmed up. They're finished drying now, so they're completely hard. What I did, I'm not sure if I showed earlier, but I went ahead and cut the slits where the fins go. So that's been cut, cleaned up the interior of the tube a little bit where some of the adhesive had wicked in through those slits. These are the fins. There's 3 of those made out of some kind of fine plywood of some sort. I beveled the leading edge of the fins. You can see how it's kind of more towards a point. I used a belt sander at work to do that. And we took our engine tube, the fiberglass tube, and we took you see a JB weld, and we weld the cap, the engine retainer ring, onto the end of the tube. I had to do some sanding. So basically you can see here how the tension cap goes on. So engine to go in there. And you got a cap that holds it. So there's 3 wood spacers that center the engine tube in the rocket. This one was put on at the same time with the engine retainer. We use JB Weld. JB Weld is the epoxy that withstands a lot of heat. It's used a lot in automotive. So these were we basically butted the wood centering ring up to the retainer. And then last night I epoxied this retaining ring and the top. So the spacing of this tube is not really, the centering ring is not really critical. I just put it 1 inch away from the tube. The only one that's really critical is the proximity of this one to the back tube. And the point is there's a tab for the fin that goes through the engine tube. Well, not the engine tube, but the booster tube goes in like that. And basically that goes in, and you want that to go in between the 2 rings, like so. And so that's why that alignment. So these actually glue to the engine tube and the 2 centering rings. And the idea is the fins, the centering rings, everything are attached to the engine tube. The engine tube is getting most of the stress, so everything anchored down to this common tube pretty much lifts the rocket up in the air. So we want everything to go through the exterior tubes and anchor to this tube, and that was one reason why it was probably better to go with a fully fiberglass tube rather than fiberglassing over the original cardboard tube, because you really need a strong structure here for what we're getting ready to do. So this is the gluing of this side of the ring and this ring and this ring is using a very slow aero epoxy. Aero epoxy has a setup time about 3 hours. So when you mix it, it's milky. You put it on, you got a long working time before it starts setting out. So I did this last night, so it glued. So I did this side. I got to glue the top. I glued one side of this. So tonight I've got a fixture that I set up to align the engine tube relative to the booster tube and the fin. So what we'll do is we'll put the engine tube into the booster tube, and then we're going to put the fins in and actually spot glue them to the engine tube. We'll take the engine tube back out and finish adding epoxy, but for right now, this alignment, placement, we'll put all this together and we'll put a little bit of glue just to tack it in place so we can remove it. Okay, it's September 18th, it's Friday, and I left off talking about how I was going to put the engine tube into the booster tube, and then basically tacking the fins in. So you can see here I've got a piece of cardboard on top of a foam board. We've drawn out the diameter of the booster, and then 3 lines at 120 degrees. And you can see I put the some toothpicks into the foam. So the idea is the motor mount is up in place. We had put a little bit of glue on the motor tube. Once it was up in the booster tube, we then put the fins through the fin slots, aligning it up with the pattern, stake them out with the toothpicks, and basically put enough glue to tack them in place. So the idea, if I did this right, the centering rings and the engine tube are tacked to the fins, and now I can push that assembly out of the booster tube, and the fins should stay attached to the engine tube, so we can separate those, and then we can go back to putting more glue now that they're aligned correctly. So this whole purpose was just to align the fins where they're square relative to the booster tube and at the proper angles. What we also did is went ahead and took the coupler tube. This is the booster tube extender. Again, the one that only has the 5 ounce. So we put glue on the inside, glued this ring in. This ring is 6 inches long, so we split it in half, go 3 inches. So this is glued in place. Once we're done with the fins, this is the tube that will actually go on the end up here. We'll glue those two together, and then that's when we'll coat both the tubes with one continuous length of 3 ounce. So the idea is this seam here would be invisible. This would be a non-breakable seam that will become part of the booster tube itself. So with any luck, I'm going to pick this up now, and I'm going to separate the engine tube, and hopefully the fins will stay intact with the engine tube, so the fins will come off with the engine tube, and we'll start doing the more thorough gluing of the fins to the engine tube. Okay, so everything seemed to work out good. You can see I separated the motor tube with the fins intact from the booster tube. So fortunately none of the glue wicked out and made it where it was difficult to get the motor. So you can see I've got a little bit of glue on here, but now we're going to do a fillet and put like a bead around all this to get it all lined up. So engine cap, engine retainer, the rear centering, the fins, middle centering, and the forward centering.